Hello guys, welcome to the next class. In this class, we'll discuss some advanced problems on limits. Let us start. First one is if f of x equal to 8x cubed plus 3x, find limit x tends to infinity f inverse 8x minus f inverse x by x power 1 by 3. We can pause and give it a try. Let us start discussion now. The answer for this problem is 1 by 2. We can see the solution now. We'll split the limit here. We have limit x tend to infinity f inverse 8x minus f inverse x by x power 1 by 3. We split here limit x tends to infinity f inverse 8x by x power 1 by 3. Let us refer to this thing as I, and limit x tend to infinity f inverse x by x power 1 by 3. Let us refer to this thing as j. So we have I minus j. Now let us see I. So limit x tends to infinity f inverse 8x by x power 1 by 3. Put f inverse 8x as t, so we can say 8x will be f of t and x will be f of t by 8. So we get what? We get limit, and when x will tend to infinity, t will also tend to infinity. It's a cubic function, so we can say when x is infinity, t will also be infinity. Now, you get limit t tends to infinity, you get 2t by f of t power 1 by 3. Now, f of t will be 8t cube plus 3t whole power 1 by 3 divided by t both side. We get limit t tends to infinity 2 by 8 plus 3 by t square whole power 1 by 3. So you can say when limit t tends to infinity, 3 by t square will tend to 0. 8 power 1 by 3 will be 2 only. So this and this cancel out, you get 1. Same thing you can do for j also now. Limit x tends to infinity f inverse x power by x power 1 by 3. Put f inverse x as t, x will be f of t. When x is infinity, t will also be infinity. Now we get t over 8t cube plus 3t power 1 by 3. Again you will divide by t. Now the numerator will be 1, denominator will be 2, you get 1 by 2. So I minus j will be 1 by 2. I hope it makes sense to all of you guys. Next. F of x equal to limit n tends to infinity n time x power 1 by n plus 2 minus 1 minus 2 plus 2 into x power 1 by n plus 2, where x is greater than 0, find f of e square. You can pause and give it a try. Let us start discussion now. The answer for this problem is just 2. See how? We can rearrange this thing to write it as, you see, if you just expand this thing, get n time x power 1 by n plus 2, and here we have 2 time. So from here, you can take x thing common, you get n plus 2, x power 1 by n plus 2, minus n minus 2. So again n plus 2 common, you get n plus 2 into x power 1 by n plus 2 minus 1. So put n plus 2 as 1 by t. So when n tends to infinity, t will tend to 0. So get limit t tends to 0, x power t minus 1 by t. There will be nothing but ln x. If you remember this direct formula, we have limit x tends to 0, a power x minus 1 by x is ln a. So here the limit t tends to 0. So in place of x, we have t, and in place of a, we have x. So this will be ln x. So f of e square will be ln e square, that will be 2. Just some rearrangement here, guys. Next. Limit x tend to 0, 1 plus x power 1 by x minus e plus ex by 2 divided by x square. You can pause and give it a try. Let us start now. See guys, this whenever you have this a function raised to power another function, the best thing is like use this thing. A power b you can write as e power b ln a. They're same things only. So use that, you get e power 1 by x ln 1 plus x minus e plus ex by 2 divided by x square. Expand ln 1 plus x, like with expansion here. We get x minus x square by 2 plus x cube by 3. You see in the denominator have x square. So I'll expand this thing up to x cube, so that this 1 by x outside will make it x square. Higher bars will not be required if in the denominator you have x square. in the numerator also, everything you expand up to x square only. So here, because of this 1 by x outside, expand up to x cube. So when you expand, you get 1 minus x by 2 plus x square by 3 minus e plus ex by 2 whole divided by x square. Now you take e common from all this, get e outside, you get e power minus x by 2 plus x square by 3 minus 1 plus x by 2 by x square. Again, we use expansion here. Expansion of e power x will be 1 plus x square by 2 factorial and so on. Again, we expand up to square only because higher power will not be required. So 1 plus minus x by 2 plus x square by 3 plus minus x by 2 plus x square by 3 whole square by 2 factorial minus 1 plus x by 2. When you expand all this and this will get cancelled out. You get x square into 1 by 3 plus 1 by 8. All the higher power of x will ignore. It goes in the denominator here x square. So this x square x will cancel. We get 11 e by 24. E was outside. I hope it makes sense, guys. Next. Limit x tend to 0, x power 1000 minus sin x power 1000 by x power n is equal to capital M. If capital M is non-zero finite, find small n minus 6 times capital M. You can pause and give it a try. Let us start discussion now. The answer for this problem is 2. You can see how. So x power 1000 as it is, expand this sin x thing, you get x minus x cube by 3 factorial and so on, whole raised to power 1000. Now take x common from here, we get x power 1000 minus x power 1000. Inside will be 1 minus x square by 6 and so on, whole raised to power 1000 divided by x power n equal to m. Now here, if I use that thing, 1 plus x power n, we can write as 1 plus nx. So become 1 minus 1000 by 6x square. Okay, so when you expand this thing now, you'll get x power 1000 will get cancelled out. You just get 1000 by 6, x power 1002. Only the least power of x is required, rest all we can ignore. So I'm ignoring the terms here also and here also. But like when we use 1 plus x power ns, 1 plus nx, all the remaining terms of expansion I'm ignoring there because we just need the least power of x because you want to make it non-zero. So now if I make n as 1002, so this and this will get cancelled out and capital M will become 1000 by 6. All the higher powers of x will automatically be 0 then. Like when you put x as 0, they all become 0. To cancel out this x power n, we just need the first x only. And that is possible when n is 1002. I hope it is clear, guys. Next. We have limit x tend to 0, a sin x by x plus b cos x plus, now this is step here, x by sin x minus 1 whole divided by x square equal to 4. This is step function, find a comma b, a and b. You can pause and give it a try. Let us start discussion now. First of all, if you see this thing, if you remember, x by sin x will be slightly more than 1. When you subtract 1, you get slightly more than 0, and step of that will be just 0. So this thing is exactly 0. We just ignore that now. We don't need to use any limit or anything there. This number is slightly more than 0. Step of that is exactly 0. So just have a sin x by x plus b cos x by x square equal to 4. Now, what is the best way to solve this kind of problem? Use expansions. Like first take LCM, we get a sin x plus bx cos x by x cube. And as you have x cube in the denominator, expand everything up to x cube only. So you get ax minus, like a times x minus x cube by 3 factorial for sin x. Bx outside cos x 1 minus x square by 2 factorial divided by x cube equal to 4. When you expand, you get a plus b times x minus a by 6 minus b by 2 x cube equal to 4 by x cube. Now this thing can be equal to 4 only if this x cube get cancelled out, and this only get cancelled out if there is no term of x here. So coefficient of x must be 0 and then x cube cancel, then this thing must be equal to 4. So a plus b is 0, minus a by 6 minus b by 2 is equal to 4. You solve for a and b, get 12 and minus 12. I hope it makes sense, guys. Next. Limit x tends to infinity, x plus a1, x plus a2 up to x plus an whole raised to power 1 by n minus x. You can give it a try. Let us start discussion now. See, when you expand this thing, you get x power n plus s1 x power n minus 1 plus s2 x power n minus 2 up to sn. I hope you remember s1 is like sum of numbers taken one at a time. S2 will be sum of numbers taken two at a time and so on. Now here we take x common out, like x power n common out. So if we take x power n from here, outside you get just x. Then x and x will be common from there, take it in the denominator. We get 1 plus s1 by x plus s2 by x square up to sn by x power n whole power 1 by n minus 1 divided by 1 by x. Now put 1 by x as t. So if x tends to infinity, t will tend to 0. We get limit t tend to 0. 1 plus t s1 plus t square s2 up to t power n sn whole power 1 by n minus 1 divided by t. Now we can use that thing here, that 1 plus x whole power n is 1 plus nx when x tend to 0. So here you get 1 plus this whole thing, you take it as x. So 1 plus x power n will be 1 plus nx. So this 1 and 1 get cancelled out. This t, 1, like if you take t common from here, this 1 t and t get cancelled out. Remaining t you put 0, you just get limit basically t tend to 0, 1 by n, s1 plus t, s2 plus t up to t power n minus 1 sn. When you put t as 0, now you just get s1 by n. S1 is sum of numbers, so basically this is sum of numbers by n. You can remember this thing for next time will be arithmetic mean of the numbers. Whenever you see the problem, you can directly see the answer will be arithmetic mean of these numbers. I hope it makes sense to all of you guys. Next. Limit x tend to infinity, 8x cube plus mx square whole power 1 by 3 minus nx equal to minus 1. Find m comma n. Let us start discussion now. The answer is m equal to minus 12 and equal to 2. See how? I took 8x cube common from here, so outside you get just 2x. So 1 plus m by 8x whole power 1 by 3 minus n by 2 equal to minus 1. Now put 1 by x as t, again t will tend to 0, this x will go in the denominator as t. We get 2 times 1 plus m by 8t power 1 by 3 minus n by 2 by t equal to minus 1. Again yet 1 plus x power n will be 1 plus nx. So we get 2 times 1 plus mt by 24 minus n by 2 whole by t equal to minus 1. Now this t will get only get cancelled out. The constant part will be 0. So 1 minus n by 2 must be 0 and then t cancel out. You get m by 12 equal to minus 1. So m is minus 12 and is 2. Next, guys. Limit n tends to infinity, n plus 1 by n minus 1 whole raised to power n minus e square into n square. You can pause and give it a try. Let us start discussion now. First of all, in this thing, I'll divide both sides by n. So you get 1 plus 1 by n by 1 minus 1 by n whole power n minus e square n square as it is. Put 1 by n as x, you get limit x tend to 0, you get 1 plus x by 1 minus x whole power 1 by x minus e square by x square. Now, if you solve this thing separately, like this thing, it'll be 1 power infinity form, and if you solve, you get e square. And it'll be e square minus e square, so 0 by 0 form again we are getting. So what do we do here then? We do that again, that function power function is there, so a power b we can write as e power b ln a. So e power 1 by x ln 1 plus x by 1 minus x minus e square by x square. This ln A by B we can write as ln B minus ln A. Now 1 by x outside, expand ln 1 plus x, expand ln 1 minus x, and subtract them. Again expand up to x cube only because 1 by x outside. So x minus x square by 2 plus x cube by 3 minus x square by 2 minus x cube by 3. And this all you get 2 by x plus 2x cube by 3. So this x get cancelled out. You get what? You get e power 2. Sorry, it was supposed to be 2x here. It will be 2x plus 2x cube by 3. Now this one x will get cancelled out. You get e power 2 outside, and you get e power x 2x square by 3, and e square we take outside from both of these. You get e power 2x square by 3 minus 1 by x square. Now multiply divide by 2 by 3. This limit will become 1. That e power fx minus 1 by fx, when fx tends to 0 is 1, no? So this will become 1, you get e square into 2 by 3, so 2 by 3 e square is the final answer. Next one, guys. Next we have limit x tend to 0, x sine of sine x minus sine square x by x power 6. You can pause and give it a try. Let us start discussion now. The final answer here is 1 by 18. See how? Just expand here, sine of sine x. You get sine x minus sine cube x by 3 factorial plus sine power 5x by 5 factorial. Sine square x, expand sine x and square that. And I'm taking up to like 5 here. I think this 5 may not be required. Anyhow, we'll take it. So you get x minus x cube by 3 factorial plus x power 5 by 5 factorial whole square divided by x power 6. Now, here again expand sine x also, sine cube x also, sine power 5x also. Okay, I think sine power 5x you can do separately only. Yeah, basically just expand sine x and sine cube x. Sine x you expand up to x power 4 because outside x squared divided by x power 6. So we have to x power 6 we have to expand. Sine x whole cube. So here you can like see that we don't need the third term, I think, because x is outside. In sine x you will have x minus x cube by 3 factorial plus x power 5 by 5 factorial, and whole cube will be there. So third term will not be required. From here you take x outside, you get x power 4 by 4 3 factorial into 1 minus x square by 3 factorial, and this thing as it is. You take x outside, you get x square into 1 minus x square by 3 factorial plus x power 4 by 5 factorial whole square. X power 4 will be required here, so this we are keeping here, and this last thing here, x into sine power 5x by 5 factorial by x power 6. So here 1x get cancelled out, then sine power 5x by x power 5 will be 1, so you get 1 by 5 factorial from here. Now when you just expand all these things, see here when we open the cube, we don't need higher power, we just need up to x square only, so it will be 1 minus 3x square by 3 factorial. Here we use the formula of a plus b plus c whole square, and we need these terms. It'll be like a square, b square, and c square. A square and b square. C square will not be required, become x power 8. And then 2ab, 2bc, you get minus 2x square by 3 factorial plus 2x power 4 by 5 factorial. So these terms will be required. Now you will see these terms get cancelled out, these terms get cancelled out. Finally, just x power 6 term will be left. And you just cancel x power 6 from there, you get only 1 by 5 factorial plus 3 by 36 minus 1 by 36 minus 2 by 5 factorial plus 1 by 5 factorial. Upon simplification, you get 1 by 18. We can just check here. All the lower powers of x get cancelled out, only x power 6 will be left, which we can cancel out here. Next. 10th one, let fx equal to pi by 2 minus cos inverse of 1 minus fraction x square into cos inverse of 1 minus fraction x whole square divided by 2 times fraction x minus fraction x cube. If f of 0 positive is p, f of 0 negative is q, then value of p square pi by q step. can pause and give it a try. Let us start discussion. First, take 0 positive. In 0 positive, we can say, see, if I extend to 0 positive, fractional part of x will be just x only. So it will become pi by 2 minus cos inverse 1 minus x whole square. Cos inverse of 1 minus x whole square divided by 2 times x into 1 minus x square. When I put x as 0, see here, you get cos inverse of 1. Cos inverse of 1 is 0 only. So you get pi by 2 minus 0. This thing will just be pi by 2. So finite number, keep it out. Here you put x0, you get 1 only. So keep this also out. Left with cos inverse of 1 minus x whole square by x. If I put cos inverse 1 minus x as theta, 1 minus x will be cos theta, and we can say 1 minus cos theta will be x. So this thing, numerator will just become theta square, and denominator will just become 1 minus cos theta. And when x will tend to 0, theta will also tend to 0 because cos inverse 1 is 0. So we get limit theta tend to 0, theta square by 1 minus cos theta, which will be just 2 only. We have a direct formula. So this value will come out to be pi by 2. Okay, so p will be pi by 2. For 0 negative, now if x tend to 0 negative, fractional part of x tend to 1 negative. If I put fractional part of x as t, we can say it will be like t tends to 1 negative. That pi by 2 minus cos inverse something we can also write as sine inverse or something. So becomes sine inverse of 1 minus t square, cos inverse of 1 minus t whole square, 1 minus t square into 2t. Now t tends to 1. So if t tend to 1, you can say sine inverse 1 minus t. So basically like sine inverse fx by fx. When fx tend to 0, this limit will directly be 1. Sine inverse fx by fx. When fx tend to 0, this will be 1. And here if you put t as 1, you get cos inverse of 0, which will be pi by 2. So you get pi square by 4. Here you put t as 1, you get 2 only. So this will just be pi square by 8. So p is pi by 2, q is pi square by 8. When you put it here, you get finally step of 2 pi, which will be 6. Next problem, guys. Limit x tend to 0, tan pi by 4 plus x whole power 1 by x minus e square divided by x square is equal to p by q square. Then the minimum value of p by q is p plus q is. Give it a try. Let us start discussion, guys. The answer here is 7. See how? First of all, again, if you solve this limit separately, limit x tend to 0, tan pi by 4 plus x whole power 1 by x will be 1 power infinity form. When you solve that, you get e square. Again, if you put e square here, you get e square minus e square by 0. It will be 0 by 0 form. So again, function power function, I write as e power b ln a. It's like almost similar to the problem we discussed for the tan log 1 plus x by 1 minus x. Here in place of x, we have tan x. So you get 1 by x ln 1 plus tan x by 1 minus tan x minus e square by x square. Again, split them ln 1 plus tan x minus ln 1 minus tan x. Again, you split them. After simplification, this thing will be same only. You get e2 by x, e1 by x, 2 tan x plus 2 tan cube x by 3 minus e square by x square. Now 2 get cancelled. No, 2 will be outside and we can expand tan x here now. X plus x cube by 3, x plus x cube by 3 whole cube into 1 by 3 outside as it is. Now when you expand this thing, so we don't need the powers more than 3 because in the denominator we have x square, outside we have 1 by x. So only the powers up to x cube will be required. So you get this thing to be, when you solve it, you get x plus 2x cube by 3. All the higher powers of x will ignore. So here x and x again can cancel out. You can take e power 2 common from here. So e square outside, you get e power 4x square by 3 minus 1 by x square. Multiplied with 4 by 3. Again, this thing will be 1. So you get 4 by 3 e square. So p and q will be 4 and 3 respectively. So answer will be 7. I hope it is clear, guys. Next. This capital L is equal to limit x tend to 0 sine of x square plus 2 cos bx minus ax power 4 minus 2 divided by e power ax minus 1 minus ax minus 2x square minus a cube x cube by 6 where a and b belongs to integer. If L exists finitely, what are the possible values of L? There are four options also there. Now, this is a bit difficult problem. You can give it a try. Let us start discussion now. Again, first expansion only, we just expand here. You see, in the denominator, we have e power ax. When you expand that, you get 1 plus ax square by 2 factorial plus ax cube by 3 factorial and so on. 1 ax will get cancelled out. You get a square x square by 2 factorial, a cube x cube by 3 factorial. This get cancelled out with this last term. Plus a for x power 4 by 4 factorial minus 2x square. It's expanding up to power 4 only right now. So, and in the numerator also, if you like expand here up to power 4, so sine x square, just take first term only, next will become x power 6, not required for now. Cos bx also expand up to x power 4, and we have x power 4 minus 2. So this x square, I think, sorry, the constant get cancelled out, and we have x square and x power 4 terms left. X square we cancel out from numerator and denominator. We get 1 minus b square plus b square by 12 minus a into x square. A square minus 2, a square by 2 minus 2 plus a power 4 by 24 x square. Now, first of all, if you see this thing, if b square is 1 and a square is 4, this thing will be 0, this thing will also be 0, then we come out to be on this quadratic. So this and this will cancel out, the limit will come out to be b square by 12 minus a by a power 4 by 24, and all those values we have. B square is 1, so you get 1 by 12, and a will become plus minus 2. So 1 by 12 minus plus minus 2 divided by 2 by 3. Because a power 4 will, you can write from here, will be 16. So when you solve, you get ls 25 by 8 or minus 23 by 8. That is the first scenario when b square is 1 and a square is 4. Second case, if a square is not if a square is not 4, if a square is not 4, then we can say that this thing will not be 0. If this thing is not 0, that means we have to put x 0, this will become 0, this will become 0, limit will come out to be just 2 times 1 minus b square by a square minus 4. Okay, if constant get cancelled out, then we come to this x square term. But if this constant doesn't get cancelled out, we get a non-zero number here only, so you can directly put x 0. You get some finite by finite only. Now here, 2 times 1 minus b square by a square minus 4. Now there is no direct way here, like there will be infinite values for L. We just have to see which of the following option can work, because a and b has to be integers. So you can say which of the options can give you a and b option. So see right now, we got 25 by 8 minus 23 by 8, which are, this is D option we get right now. A, B, C will have to check. So first we see 1 by 2. If you put 1 by 2, you get a square plus 4b square equal to 8, which is not possible because a square is not equal to 4 here. This could have been possible if a square you take as 4 and b square you take as 1, but we can't do that. A square is not equal to 4. If a square is not 4, then this cannot be equal to 8. So this thing cannot be equal to 8. So this is not possible. Second, when you equate this thing to 1 by 8, you get a square plus 16b square equal to 20. This also would have been possible only if a square is 4. A square 4, 16b square 1. Like b square as 1, you get the thing, but here also not possible. If we take minus 4 by 3, we get 2a square equal to 5 plus 3b square. Now this is possible when b square is 9 and a square is 16. So only option possible is C and D. That's all guys for now. Bye bye.